Let's continue our work with solving right triangles using trig ratios. In triangle QRS, the measure of angle S is 90 degrees, the measure of angle Q is 63 degrees, and SQ is 7 feet. Find the length of RS to the nearest tenth of a foot. So let's call RS, that unknown length, let's call it X. Let's realize that this is not a special right triangle, although it looks like a 30, 60, 90. It's not exactly that. So we will use our trig ratios. SOHCAHTOA stands for sine, cosine, and tangent. And when we look at our diagram, the two sides that are given in the triangle are the opposite side to 63 degrees and the adjacent side. Notice we know nothing about the hypotenuse, so we will not be using sine or cosine. Instead, we'll use tangent. And we'll write our equation. The tangent of 63 is equal to x over 7. To solve for x, which is being divided by 7, let's multiply by 7 to both sides. And at this point, we can type that into our calculator and round to the nearest tenth of a foot, and we get that x is approximately equal to 13.7. And we always look at our diagram and make sure that that makes sense with the way the diagram looks. The length of RS is approximately 13.7 feet. Directions for this problem say to draw and label all three sides and angles of a right triangle that has a 40-degree angle as shown and a hypotenuse of 10 centimeters. So once again, this is not a special right triangle. It's not 45, 45, 90 or 30, 60, 90, so we'll use trig. And we are looking for all three side lengths where one of the sides is given. So let's look at this height and call it x and realize that in relation to the 40-degree angle, it's the sine. It's the opposite over the hypotenuse. We can write an equation that the sine of 40 is equal to x over 10 and solve for x. Let's multiply both sides by 10 and now enter this into our calculator. X is approximately equal to 6.4 centimeters. Glancing at our diagram, making sure that makes sense. And so we'll replace that with 6.4 centimeters. Now we need the third side of our triangle. We can call it y. Now at this point we could apply the Pythagorean theorem. We absolutely could, because we have two of the three sides. We could apply a squared plus b squared equals c squared. But that height that we have labeled there is not the exact height, so I think it's better to use another trig ratio. When we're looking for side y, that's the adjacent side to the 40-degree angle, and we have the hypotenuse. Let's use the cosine. And let's write a trig equation. Cosine of 40 is equal to y over 10. Solving for y, let's multiply by 10 to both sides. And let's type this into our calculator and get y is approximately equal to 7.7 centimeters. The directions did say to label all three sides and all three angles. So that top angle by the triangle sum theorem would have to be 50 degrees because the sum of the three angles of any triangle is 180. We have one last problem. It says to draw and label all three sides of a right triangle that has a 60-degree angle as shown and a hypotenuse of 22 centimeters. So here's what we are looking for. We're looking for the remaining two sides. Let's start by finding the height. Let's call it x. And in relation to that 60-degree angle, x is the adjacent side and 22 is the hypotenuse. So we are thinking about the cosine. And we can write our equation. Cosine of 60 is equal to the adjacent over the hypotenuse. To solve this equation, x is being divided by 22, so we can multiply by 22 to both sides. And now we can use our calculator. 22 times the cosine of 60 degrees is 11. And I'll swap out x with 11. And all of a sudden I look at that diagram and something strikes me. And I remember, wait, when the short leg is half of the hypotenuse, isn't this a special right triangle? Isn't this a 30, 60, 90 special right triangle? So it is, in fact. And remember the way we derived this rule. If we know the short leg length, in this case it's 11 centimeters, and we're looking for the long leg, the side opposite the 60 degree, we take whatever the short side is, multiply it by root 3. So the base of this triangle is going to be 11 root 3 centimeters.